Okay, we'll begin our unit on exponents and exponential functions as we begin to discuss the rules of exponents. I'll begin the basic exponent rules today. And you've learned before on exponent, you have the base number and the exponent. So if I have 4 to the third power, it means repeated multiplication. Exponents are shorthand for repeated multiplication. Means I'm multiplying the base number 3 times. So 4 to the third power means 4 times 4 times 4. So if you keep that in mind, it'll help you as we simplify and find patterns within different exponent properties here. So first we'll explore the product of powers property. And in order to figure out what the rule is, it's helpful if we just take a look at what the exponents mean. So we have 3 squared times 3 to the third. 3 squared means 3 times 3. 3 to the third is 3 times 3 times 3. So we're multiplying 3, and multiplication is commutative, so it doesn't matter the order. So if we combine it all, really we're multiplying 3 5 times, which simplifies as 3 to the fifth power. If I use a variable, a to the third is a times a times a times a to the fourth is a times a times a times a. I have a being multiplied 7 times, so a to the 7th power. So hopefully you can see what happens when we multiply the same base. So 3 squared times 3 to the third is 3 to the 5th. A to the third times a to the 4th is a to the 7th. So you can see the rule laid out below you. Multiply powers having the same base, we end up adding the exponents. It's important to know how it works because sometimes the rules can be confusing. We're going to come across 5 or 6 different rules, and sometimes they go counterintuitive to your instinct. So sometimes it's best just to write it out and see what happens. So why don't you try those 4 examples below and restart the video once you're ready to see the solution. So as you can see, 4 to the 6th times 4 to the 7th. If we have repeated multiplication, we have 4 6 times and 4 7 times. It's a total of 4 to the 13th power. 8 to the 5th times 8 squared. Really, that's an 8 to the first power. So we have a total of 8 eighths being multiplied together. Next, we have negative 3 to the third power times negative 3 to the second power. We have negative 3 being multiplied by itself 5 times. Now keep in mind when it's a negative, we want to keep that in parentheses because the quantity negative 3 to the 5th is different from negative 3 to the 5th. This one means a negative 1 times 3 times 3 times 3 times 3 times 3. The one we want means we're multiplying negative 3 by itself. So keep that in mind. And then finally we have x to the third times x squared times x to the fifth gives us x to the 11th. Next, we have 5 squared raised to the third power. So let's take what we know. We have 5 squared being multiplied 3 times. So when I expand that out, that's what I have, a 5 squared being multiplied by itself 3 times. I can expand that as repeated multiplication, 5 times 5 times 5 times 5 times 5 times 5. Notice I have the base of 5 being multiplied 6 times. Do the same thing, a to the third raised to the 4th power. So I have a to the third being multiplied 4 times. A to the third means a times a times a. And I have that total of 4 times. And I can see I have the same base, a being multiplied by itself 12 times. Maybe you see the connection. When I have a to the third raised to the 4th power, gives me a to the 12th. 5 to the 2nd, and that raised to the 3rd power gives me 5 to the 6th. So to find a power of a power, we end up multiplying the exponents. That's the shortcut that we do. So you can take time to try those next examples, restart it when you're ready to check your answers. So 7 to the 4th power raised to the 5th power ends up being 7 to the 20th power. Negative 3 to the 4th squared, negative 3 to the 4th 2 times, ends up being negative 3 to the 8th power. Y to the third raised to the third power means I have y to the third 3 times. Expand that out, I have y to the 9th. N plus 8 squared to the 9th means I have n plus 8 squared 9 times. And when I write that all out, I end up having n plus 8 18 times. Next one we want to take a look at is the power of a product property. That one is, if we take a look at it, we have a product inside the parentheses, so 3 times 5 raised to the power of 3. So what that means, I have 3 times 5 3 times. 3 times 5 times 3 times 5 times 3 times 5. I can rearrange the order, so I have 3 times 3 times 3 times 5 times 5 times 5, which would be 3 to the third power times 5 to the third power. A times B 4 times. I can write that out. Then rearrange A times A times A times B times B times B. Means I have A multiplied 4 times B 4 times. So you can see that we take whatever's in there being multiplied by the number of the exponent. So we find the power of each factor and then we multiply. So why don't you try those 4 examples, restart it when you're ready. First example, I have 34 to the 6th power times 9 to the 6th power. You're probably wondering, well, why didn't we multiply first and then take it to the power of 6? That would give us an equivalent expression. We're just showing you here that each factor gets multiplied that many times. 4mn to the third gives us 4 to the third, m to the third, n to the third. Quantity negative 2y to the fourth means I have negative 2y 4 times. Negative 2 to the fourth, y to the fourth. Notice I put the negative 2 in parentheses because the negative 2 is being raised to the 4th power. It's not just the 2. And finally, negative times quantity 5x squared. So I have 5x twice times a negative 1. So I have 5 times 5, which is 25, times negative 1, x times x, which is x squared. Notice I could have written that one to keep it using exponents, negative 5 squared x squared. Either one would work. Notice the negative 5 is not in parentheses because only the 5 is being squared. And then we multiply by a negative 1. Next, let's explore the quotient of powers property. Let's first of all take a look at what's going on. So 3 to the 4th is being divided by 3 squared. So 3 to the 4th means 3 times 3 times 3 times 3. And 3 squared means 3 times 3. And we know that anything divided by itself is 1. So I have 3 divided by 3 is 1, 3 divided by 3 is 1. So really I have 1 times 3 times 3 over 1 times 1. Which when we simplify it, multiply the numerator on top, I've got 3 times 3 on top, divided by 1 times 1 on the bottom. 1 times 1 is 1. Anything divided by 1 is that number. So we end up with 3 squared. So in the next example, I have a to the 6th in the numerator, which is a times a times a times a times a times a. Forgot a few a's. And then on the denominator, we have a times a times a. So we can simplify anything divided by itself as 1. So a divided by a is 1. A divided by a is 1, and a divided by a is 1. So we're left with 1 times 1 times 1 times a times a times a. Anything times itself is 1, so we have a to the 3rd power. And these are 1s on the bottom, and that doesn't affect our solution. So hopefully you see when we're dividing powers with the same base, 3 to the 4th, 3 to the 2nd gives us 3 to the 2nd. A to the 6th, a to the 3rd, same base, we get a to the 3rd. Notice that shortcut that we find is that we end up subtracting exponents. So you know the drill. Pause the video, check these examples, restart it when you're ready. So 9 to the 12th divided by 9 to the 5th. We have 5 9s that cancel out, and we have 9 to the 7th. Negative 2 to the 4th divided by negative 2 to the 3rd. It's negative 2 to the 1st, or we can just write negative 2. Next one combines what we've done before with the product of power, or rather I get the names mixed up. The product of powers property, which are tongue twisters, with our quotient of powers property. So 6 to the 3rd times 6 to the 4th divided by 6 squared. We get 2 6's to cancel out, 6 to the 5th. Next one, 1 over r to the 5th times r to the 8th. Remember, anything divided by itself is 1, so this really has a denominator of 1. And when we multiply numerators times denominators, we get r to the 8th over r to the 5th. And we cancel out and we're left with r to the 3rd. Next, we're ready for the power of a quotient property. Let's explore that one. So negative 2 over d, that quantity raised to the 4th power. So I have negative 2 over d being multiplied 4 times. So when I multiply fractions, I multiply all the numerators on top together and all the denominators together. So I have negative 2 times negative 2 times negative 2 times negative 2 all over d times d times d times d. We can simplify it as negative 2 to the 4th over d to the 4th. A over b raised to the 3rd power is a over b times a over b times a over b. Multiply numerators together, you get a to the 3rd. Denominators, they get b to the 3rd. So hopefully you see that when we take the power of a quotient, we find the power of the numerator and then the power of the denominator. And then we divide. So practice with the 3 examples in the bottom. Restart the video when you're ready. So negative 7 over x squared. You get negative 7 squared over x squared. If I want, I can evaluate negative 7 squared, which would be negative 7 times negative 7 to get 49 over x squared. C over d to the 5th becomes c to the 5th over d to the 5th. 4x over y to the 3rd becomes 4x over y times itself 3 times. It becomes 4 to the 3rd x to the 3rd over y to the 3rd. If I want, I can simplify 4 to the 3rd to give me 64 x to the 3rd over y to the 3rd. Alright, so let's put it all together and see if we can combine all of these properties and see what happens and simplify it as far as we want. So for simplifying, we want to eliminate parentheses, make sure each base appears only once, so we can't have an a to the 4th over a squared. We only want one variable or one base to show at a time. We want to evaluate those powers with numerical bases as I showed in the previous slide. And we haven't talked about negative exponents yet, but when we simplify, we don't want negative exponents. So we won't have any of those today, but we'll talk about those next time. So let's take a look at the first example, show you what it looks like, and then I'll have you try the next 2. So 3a to the 4th over 5b, all that raised to the 3rd power. What that means is I have this whole quantity raised 3 times. So 3a to the 4th over 5b times 3a to the 4th over 5b times 3a to the 4th over 5b. You can apply what I know about multiplying. So 3 times a to the 4th. So notice, since the a is raised to the 4th power, it's not 3a to the 4th power. That would be this case, if it's all in parentheses, but it's not, so it's just the a being raised to the 4th power. So really I have 3 times a times a times a times a times 3 times a times a times a times 3 times a times a times a times one more a. All over on the bottom we have 5 times b times 5 times b times 5 times b. So as we organize it all, we've got 3 times, so 3 to the 3rd, a to the 4th, 8 12th, over 5 to the 3rd, b to the 3rd. So we've got each base appearing only once. We've gotten rid of parentheses. We haven't evaluated powers of numerical bases yet, so let's do that. So 3 to the third. 3 times 3 is 9, times another 3 is 27. And 5 to the third, 5 times 5 is 25, times another 5 is 125. B to the third, and we don't have any negative exponents, so that would be as simple as we can go. So why don't you try those next two on your own, see if you can get those. Restart it when you're ready to check. All right, so let's take a look at example 2. First, I have x to the third over y 7 times 1 over 3x to the eighth. I expanded out x to the third and wrote that out 7 times 1 on top, and then y times y times y, 7 times 3x to the eighth. I wrote x times x 8 times. Next, I divided x by x 8 times. So I canceled out 8x's on the bottom and 8x's on the top. So I was left with x 13 times on the top in the numerator and y 7 times 3 in the denominator. So we've got each base appearing only once. We've evaluated the powers of numerical bases. No negative exponents. Notice we want to put the numerical bases first before the exponents, or the variable exponents. That's typically the way we want to write them. Next we have negative 5 over x squared and 2x to the fourth over y to the third squared as well. So I have those written out. I expand them, so negative times negative. I'm going to say I have negative 1 times negative 1. And 5 times 2 times another 2. X to the fourth and x to the fourth on the numerator. X and and y to the third 2 times in the denominator. I divide 2 x's on top and 2 x's on the bottom. So that leaves me with 5 squared, 2 squared, x to the sixth, and y to the sixth in the denominator. Negative 1 times negative 1 is just a positive 1. So I evaluate my numerical bases. 5 squared is 25, 2 squared is 4. 25 times 4 is 100. X to the sixth over y to the sixth. So those are all the rules of exponents. You'll be applying those. And keep in mind there's always shortcuts and patterns that we found that can help you do these a little bit quicker. But sometimes it's better and it helps you understand if you just write out what's going on if you haven't gotten the hang of that yet. So do the practice, and if you have questions, I'll take care of that in class.